Hi everyone, I'm Gohar Ghazaryan from Ruhr-University Bochum, and I would like to present our work entitled Citizens and Satellites, Multisource Monitoring of Urban Sprawl based on Remotely Sensed Time Series and Crowd Mapping in German Metropolitan Regions. With the continuously increasing urban population and their footprint, the need to assess, map, and quantify the dynamics of urban environment and the impact of these changes increases. Coupled with climate change impacts, improving the climate adaptation competence of cities is essential. In this study, we developed a framework for analyzing urban growth degrees of imperviousness in North Rhine-Westphalia in Western Germany. And we observed these changes from 1980s to date while integrating citizens for developing climate adaptation strategies at once. As main data source, Landsat time series were used, and following the preprocessing of the images, several indices were estimated, and composites were calculated for growing season and full year of selected time steps. For initial 2017 time step, official geodata from German Authoritative Topographic Cartographic Information Systems, ATKIS, were extracted in order to generate label data for 10 classes, including 3 classes representing low, middle, and high level of imperviousness. For retrospective classifications, such as for 2015, the output of 2017 classification and information based on radiometric bitemporal change detection was used for preceding years. We used MODIS and Landsat-based land surface temperatures to estimate the changes and hotspots in the temperature, and as well as to map these hotspots. And the local knowledge of people was integrated through trainings with the help of science cafes, workshops, summer schools. The scientific methods and paradigms were again imparted to the citizens through several discussions, as well as large amount of geodata was generated, which was later used for comparison with remote sensing output. Here are some examples of our output. So probability of imperviousness in 2017 and the land use with 10 classes. All the maps were integrated in a web portal where land use maps and the changes between different years can be assessed. The combination of different remote sensing metrics provided information for accurate output with the accuracies higher than 80%. According to our results, the imperviousness areas continuously grew from 1985 to 2017, with high imperviousness class increasing by more than 100,000 hectares. This information can be found in the WebGIS. In addition, Landsat data were used to estimate recent trends in land surface temperature and to identify the hotspots of increased temperatures. In general, we observed 2 to 3 degrees of increase in temperature in both urban and rural areas. However, since 70% of inhabitants live in cities, the satellite-based analysis were combined with the in-situ information gained by crowd mapping. So local knowledge, such as information on areas with good practices, as well as the areas where there is need of action, such as the areas which are too hot, which are too sunny, were gathered. And also several suggestions were collected, such as the use of green roofs or solar panels. Overall, we had around 400 contributions. So here we could see that first crowd mapping enhanced the extensive land use information with point-by-point information to validate the land surface temperature increase in different hotspots. And it was shown as well that the citizen science can help with not only data collection, but also letting the participants in research and also regional planning. Some remarks on our further work. We are planning to implement the full framework in Google Earth Engine and also simulate spatially explicit urban growth by 2030. We will compare our output with other similar products and in general map the climate landscape in our study area and derive different metrics. In general, with this example, we can see how local knowledge of people is integrated with remote sensing data to detect call for actions, potentials, and best practice examples related to climate adaptation of growing urban systems. Further information can be found in our web pages, and thank you for your attention.